Hey guys, welcome back to SAT question of the day, and today we're doing a long form explanation of yesterday's question of the day. So this was yesterday's question, which was December 29th, 2025, and it asked this: the expression 6 fifth root of 3 to the 5th times x to the 45th times the 8th root of 2 to the 8th times x is equivalent to ax to the b, where a and b are positive constants and x is greater than 1. What is the value of a plus b? So, last explanation, we tried a guess and check method. And there's multiple different ways of solving this, and I'm going to show you 3 different ways to do it. One algebraically, one using Desmos and linearizing graphs, and the other one using a guess and check method, because it's always good to know that method in case you're ever taking the SAT and you don't know how to do a question. You can at least understand how to guess and check, to at least have a chance of getting the question right. It's obviously not the most perfect way of answering the question, but it's also an important skill to know in case you don't know the question, you still have a chance of getting it right. Because the SAT doesn't ask you to show your work, it asks you for the correct answer. So without further ado, let's get started. So I already pasted our equation here into Desmos, and the first method that I'm going to show you is using algebra. So essentially, we're going to look at this first part of the equation. To type this into Desmos, if you need like the nth root of something, you can go to functions and type on and press this button right here. Scroll to the very bottom, and it's this one right here. So let's start with looking at the first set of equations, or the first part of this problem. This is what we have. It's the 5th root of 3 to the 5th times x to the 45th. And now, when you are looking at exponents like this, essentially you have to remember that there's a few different rules for exponents. So when we have this, you can essentially rewrite this inside of the equation as this, and then to the power of 1/5. Because as you can see here, these equations overlap, showing that they're the exact same thing. And now, when you're looking, and now exponents with this rule, essentially, you're just multiplying these exponents to each other. So you're multiplying 3 to the 5th to the 1/5. So it's pretty much 5 times 1 to the 5th, times 1/5. So what is 5 times 1/5? That's 1. So we can rewrite this as 3 for the first one, 3 to the 1, which is just 3. And now the second part is x to the 45th. So what's 45 times 1/5? That is 9. So we have 3x to the 9th. And as you can see, this also overlaps perfectly, which shows that it is that it's the same thing as this first part of the equation. So let's start with that. That's our first part of the equation. Now let's look at the second part, which is this. So this is, again, the same thing. We can rewrite this as 2 to the 8th times x, and then to the power of 1/8. So what is 8 times 1/8? 1. So 2 to the 1 is just 2. And then what is x, or what is 1 times 1/8? 1/8. So this is just x to the 0.125. It's either 1/8 or 0.125. Either one works because they're the same thing. And as you can see here, it's overlaps, showing that it is the same equation. Okay, so now we have that settled. So this is pretty much our rewritten equation right here. So now we can combine some like terms. So we can combine this 3 and this 2 to get 6 times 6, and then we can also combine these x's. So what's x to the 9th times x to the 0.125? When you're multiplying them across, you have to add the two exponents. So in this case, it would be 9 plus 0.125. So it would be 6 times x to the 9.125. And then we now just have to distribute the 6 to the rest of the equation. And that gets us 6 times 6, which is 36. So 36 to the times x to the 9.125. So now if we look at the original equation, what is the value of a plus b? It is 36 plus 9.125, which is 45, which is 361 over 8, which, if you saw my short, is the correct answer. 361 over 8. So that's method 1 of solving it, which is algebraically. Okay, so what is the second way of figuring out this equation, you may be asking? So the second way is by using logs. So this is in an exponential form. This is this equation to the 1/5 and this to the 1/8. So if we set this equal to f of x, we can then take the natural log of f of x. And essentially what we're saying is that if we need to rewrite this into ax to the b form, then the natural log of ax to the b is, in linear form, would be the natural log of a plus b times the natural log of x. And this is essentially linear when it comes to this. So that's the theory behind it. So in this case, now that we have the natural log of this, we can then figure out the slope. So we can take the, which is y2 minus y1 over x2 minus x1. So we can then take ln f of e, so the natural log, so the y value of e, okay, minus ln f of, we'll say 1 here. Let's close this in parentheses so Desmos knows. And then divided by natural log of e minus natural log of 1. And that gets us 9.125. So if we're looking at this in ax to the b form, we essentially solved for our slope, which is b in this case. So we can set this b equal to this. So b is equal to 9.125, which, as we saw in our other method, this was the slope, this was b. So now we need to figure out how to solve for a. So essentially, what we're going to do is we're going to set x equal to 1. And whenever you raise x to any power, or the number 1 to any power, it's still going to be 1. So if you raise 1 to the 1, it's 1, 1 to the 2, it's 1, 1 to the, 8 trillion, it's still 1. So essentially, if we set x equal to 1, no matter what the value of b is, it's just going to be 1, so it's going to be a times 1, and it's going to output a number, and a is just going to be our a value, so it's going to output our a value. So if we take what f of 1 is, so when x is 1, what is y? That's essentially what this is saying. So that's saying that a is then equal to 36. So this essentially can be rewritten into 36x to the 9.125. And see how that overlaps perfectly? It's the exact same equation. So we now know that a is this, b is this, so we can say what is a plus b? And 361 over 8, which is correct. And so now, let's do a third method. Third method, which is an educated guess and check. So if we have our equation here, f of x equals this, we can then do essentially what we did, but only for the a value. So in this case, remember, we have to write it into ax to the b, so we have to solve for a. So a is pretty much f of 1 is 36, because if we're taking this original equation, and then we're finding what is the value, or what is the value of y when x is 1, then we're just solving for a. It's going to say this equals y. So we know that f of 1, so if we take this, replace this with 1, no matter what the value of b is, it's just going to be erased. It's going to be like gone. So that's going to say that when the value of x is 1, 36, or y is 36. So it's just going to set a is equal to 36. So that's essentially what this is saying when we set x equal to 1. So we know that our value of a is 36. So we can do 36 times x to the b, and we can set a slider for b. So we know that b obviously has to be greater than 0. so it can't be negative. So let's just start sliding and see what matches up. So 9.1 gets really, really close. Let's go one more over. 9.2 is over. It goes past the line, so it's something between that. So we can say between 9 and 9.5, for example. Let's keep sliding. And it's like right around here. So that's not quite it. Oh, but look at that. See what happens when we do this? 9.125. It matches over perfectly. So if we take away this line, or take away this line, it overlaps perfectly. Because 0.124 is too small, 126 is too big, so that's 125. And so now we know that our value of b is 9.125. So that we can do again, 36 plus 9.125 is 361 over 8. So this is a very educated guess and check. And you can also solve this by doing any combination you want, whether you want to see that 1/5 times 45 is 9, and then 8 times 1, or 1/8 times 1 is 1/8, so you know that your value of b is going to be 9.125, and then you can just guess your a from there, or you can do your f of 1 equals a and figure out that, or if you want to guess and check, any combination will work. And the SAT isn't going to ask you to show your work and figure out exactly how to do it. I'm trying to show you a way that you can do it definitively, so that if you understand it, you can do this when you get to the test, but also a method to show you how to guess and check. If you don't quite know how to actually do it, you can at least have a chance at getting it right by guessing and checking, or by testing other methods, seeing what works. So here's 3 different ways of doing this question. So we know 361 over 8, 361 over 8. Whether you choose algebra, whether you choose doing it logarithmically, or whether you want to do it guess and check. So thank you guys so much for watching. Have a great rest of your day, and I'll see you in the next one. Peace.